Hi, this is Tommy. Welcome to the demo video of Image Chat. Image Chat is an AI chatbot that is able to crawl any website, and then you can use natural language to chat with it to retrieve the most relevant images from the website. This is very useful as there will be cases where there are thousands of pictures in an image-rich website like Apple.com. It will be really hard to manually look for the images that you might be interested in. Then let's get started. Okay, so you need to enter a website to crawl. Image Chat has a very simple interface. You can just enter a website to crawl that you want to chat about. Then the image chat server will be able to work on crawling, partitioning, and then load the images to our backend services. We first enter a URL and then we enter the pages to crawl, and then we can click on crawl website. So we can see the live status. This is working. Under the hood, we are using Firecrawl for the website crawling. This might take a while, so I'll show you how things go on under the hood. First, we can see our Firecrawl. We have currently 0 concurrent browser working right now. So I suppose the crawling is done. So it is extracting images directly from the crawled content. So the crawling is done already. And then we can see from this session ID, then after finish crawling everything, we will load the crawled content into this Pinecone vector database. You can see, oh, we have our session right now. It's still loading, number of records 500, 700. Here we can see, we can check the live status as well. Here we can see we are only crawling 10 pages, and then we already have like more than 10,000 documents to parse. Because of the uploading rate limit for Pinecone, we will have to partition our crawled pages and then load it to Pinecone chunk by chunk. This will take some time, so we implement a indexing progress bar. You can see here the page is not dead yet. I think we should just fast forward to the time when our page loading is done. So welcome back. For the sake of time, I've skipped the loading and indexing phase of image chat, as it really takes some time. I've also tested out the search feature to try to give you a quick walkthrough, as it is hard to actually manually verify if an image exists on a image-rich page. But I have picked up some good example to get you through. For example, here we are looking for what an iPad looks like. We got this picture, and this picture exists at the very bottom of its source page. We can see here. And then another example is we are looking for Apple Pencil, because Apple Pencil is usually associated with an iPad on an iPad page. So we can see this Apple Pencil picture alone, and also this image, a man holding an Apple Pencil along with a bunch of iPads. And then we can see iPhone. iPhone is here. An iPhone viewing an iPad mini and more. But I guess you already get an idea of image chat, and that's it for the demo. I do think there are some areas that I can improve on the image chat. For example, the current searching algorithm is to identify best relevant images by its surrounding text. So you can see, yeah, I have mini Apple Pencil is being used to take notes. So this is the reason why we picked this picture. And maybe we can add some visual clues to make our image search more accurate. The database indexing time can be definitely improved as well. But I think being able to use AI to dynamically load relevant images from a website with thousands of images, it's an achievement. With this, I think there's a possibility in the future where we can dynamically assemble a web page for each individuals based on their interests. I guess that's it for the demo. I will briefly go through the code and some other aspect of the project later. Here we are at the brief code workthrough section of this video. I would like to share about how I get started with this project and how I slowly build it up. You can see in this section, MVP, my approaches for the backend is actually start from a single file, start from a single service that I want to learn about, and then slowly expands its functionality. We can see we have this here, Firecrawl. This is how I play around with the Firecrawl API, and then it progressed to using Firecrawl to download HTML pages, like on local on the file, and then it slowly progressed to adding Chroma vector database to search on all the pages that we crawled on. And then I realized that a lot of the image-rich pages, each image will have like duplicated version just to fit on different sides of the screen. And then I started to work on a script that is able to remove the duplications. And then once this is done, I started to trying to convert this whole service into a Flask API endpoint or Flask API server. And then I did break all the code down into different modules for code readability and maintainability. And for the front end, I like to choose to use Lovable.dev to start with the visual template. The reason why I choose Lovable is that I can sync up my project with Git so that I can work on the same project with both Lovable and Cursor at the same time. Sometimes Cursor does a certain job better and sometimes Lovable works better. Here I'm going to talk about some of the problems I met when I was working on the project and my solution. The first issue on the backend is that our previous approach, as I mentioned, we will crawl the URL and download the HTML and then load all the HTMLs in this folder to the vector store. The issue is that writing HTML files onto disk, it requires a lot of disk write time. So the solution I have implemented is to directly pass the crawled HTML pages to vector store, so it will reduce some of the latency. The second issue is that there are upload rate limit in Pinecone vector database. So I cannot just upload all the HTML to Pinecone all at once. The solution I did is to break down the documents into batches. For say I have a huge HTML page and then I need to break them down into multiple pieces to vector database. The code logic is here. I'll just break things down and then also return the progress of uploading. This is how the front end can get the live upload status. And the third obstacle I have met is in image search. In an image-rich website like Apple, almost every image comes in different sizes. For example, Apple will have an image of a man holding an Apple Pencil picture that is suitable for computer view, along with a smaller version of the same picture for the phone view. Technically, they are different images with the same high relevance score to the vector database. But as a user, we want to see 5 visually different images from the query result. To mitigate this, I have implemented the alt text deduplication method. What it does is that we will query an image with along with its text description. If we have seen the same text description multiple times, that means there's a high chance we have already considered this one of the version of this image. So we won't want to consider this image as our query result anymore. Of course, I have met like more obstacles or problems during the project, but I think that's the 3 main ones I want to discuss in the video. And at the end, I would like to share some thoughts about this project. I think this method of dynamically loading pictures from websites is very cool. And I believe if we are given a template, we can use AI to dynamically customize web pages in just minutes or seconds. To me, it feels like a recommendation system for the future. Just like how TikTok is feeding us the videos, we can feed users with a lot more customized elements. The second thing is that I didn't use Cursor Memory Bank in this future. As I was trying to test out how powerful is the new Cloud 4 AI model, it turns out Cloud 4 is great, but I think it is still better to have a way to give the model a project-based persistent memory. And lastly, I would like to say, working on this project has helped me improve my knowledge in the industry. I started to know Firecrawl, and I had a better understanding on vector database, how to partition, how to search. And this project has helped me to discover some of my preferred patterns to work with AI, even though they might have some conflicts with the modern software engineering practice. At the end, I would like to say I can see the AI era is coming. I will continue to learn and grow towards my goals to better utilize AI to solve real world problems. Thank you for watching.